and today we will discuss. Hello students, welcome to our live APS classes, and as all we know that this is the foundation course especially for the students from 9th to 12th, and in our today's live lecture we will discuss or we will continue with our new chapter, that is chapter number 2, and the name of the chapter is solutions. And regarding this chapter, we will discuss important 25 MCQ questions or objective questions from this chapter. So first of all, welcome to all the students who join with us our live APS classes. And this is the syllabus for term 1 examination that is to be held in November 2021. So before starting this chapter, we will discuss a brief introduction regarding this chapter, that is the solutions. So here a solution is a mixture of two or more components, and this chapter helps to understand the concentration of the solutions, types of solutions, vapor pressure of liquid solutions, solubility of the gases and solids in liquids, ideal and non-ideal solutions, Raoult's law, and various problems based on finding the molarity, mole fraction, mass percentage, and Henry's law constant are also present here in this chapter, that is the solutions. So let us start with first question from this chapter, and your first question is: the osmotic pressure of a solution is directly proportional to. Options are molecular concentration of the solute, B, absolute temperature at a given concentration, C, the lowering of vapor pressure, and D is all of the above. So here beta you will find out the osmotic pressure of the solution is directly proportional to either the molar concentration of the solute, तो जो osmotic pressure है solution का, that is directly proportional to the molar concentration of the solute. Second one is the absolute temperature at a given concentration, and the third one is the lowering of the vapor pressure. That means all these factors are responsible for the osmotic pressure, and osmotic pressure is directly proportional to all of these factors. So here option D is the right answer for the question number 1, that is all the above. All the above. Next is the question number 2, and your question number 2 is isotonic solutions are the solutions having the same. Option A, surface tension, B, concentration, C, osmotic pressure, and D is viscosity. So isotonic solutions are the solutions having the same surface tension, concentration, osmotic pressure, as well as viscosity. So here beta isotonic solutions are the solutions having the same osmotic pressure. Osmotic pressure. So here option C is the right answer for the question number 2nd, that is isotonic solutions are the solutions having the same osmotic pressure, not surface tension, not concentration, and not viscosity, but isotonic solutions are the solutions having the same osmotic pressure. Next is the question number 3, and the question number 3 is which of the following is the colligative property? Options are osmotic pressure, B, boiling point, C, vapor pressure, and D is electrical conductivity. So out of these properties you have to find out which has the which of the following is the colligative property. So here beta osmotic pressure is a colligative property, not boiling point, not vapor pressure, and even not electrical conductivity. So here option A is the right answer for the question number 3, that is osmotic pressure is the colligative property. Next is the question number 4, and your question number 4 is which of the following solutions has the highest freezing point? There are following solutions and you have to choose which solution has the highest freezing point. Options are 0.1 mole sodium chloride, second one is 0.1 mole barium chloride, third one is 0.1 mole aluminium sulfate, and last one is 0.1 mole here. So out of these following solutions which has the highest freezing point? तो जिस solution का सबसे highest freezing point है बेटा, that is 0.1 mole urea. So this is the solution which has the highest freezing point. So here option D is the right answer for the question number 4. Next is your question number 5, and the question number 5 is which of the following 0.1 mole aqueous solution will have the lowest freezing point? अब इनमें से जो 0.1 mole aqueous solution है, out of these solutions which has the highest, not highest but lowest freezing point. अभी हमने देखा कि जो highest freezing point है that is of 0.1 mole urea. But now you have to choose which of the solution has the lowest freezing point. Options are potassium sulfate, second one is sodium chloride, third one is urea, and D is glucose. So out of these 0.1 mole aqueous solutions, which has the lowest freezing point? And it is the question number 5. So बेटा यूरिया का तो अभी हमें पता है कि इसका सबसे हाईएस्ट फ्रीजिंग पॉइंट है. So potassium sulfate is the 0.1 mole aqueous solution which have the lowest freezing point. So option A is the right answer for the question number 5. Next is your question number 6, and your question number 6 is the mass of COOH twice multiplied by 2 molecules of water needed to prepare 500 ml of 0.1 molar solution is 12.6 grams, B 6.3 grams, C 4.5 grams, and D is 9.0 grams. So the mass of COOH twice multiplied by 2 molecules of water that needed to prepare 500 ml of 0.1 molar solution is either 12.6 grams, 6.3 grams, 4.5 grams, and 9.0 grams. So beta, the right answer is 6.3 grams. So here option B is the right answer for the question number 6. Not 12.6, not 4.5, and even not 9.0 grams. Question number 7. Which of the following solutions has the highest osmotic pressure? Options are 1 mole sodium chloride, 1 mole magnesium chloride, 1 mole urea, and 1 mole glucose. So out of these following solutions, which has the highest osmotic pressure? 1 mole sodium chloride है, 1 mole magnesium chloride, 1 mole urea, and 1 mole glucose. And it is your question number 7. So out of these following solutions, the solution which has the highest osmotic pressure is 1 mole sodium chloride. Has highest osmotic pressure. So here option A is the right answer for the question number 7. That is 1 mole sodium chloride. Rest are the wrong options. Next is your question number 8, and your question number 8 is which of the following solutions in water has highest boiling point? 1 mole sodium chloride. Second is 1 mole magnesium chloride, 1 mole urea, and 1 mole glucose. So out of these following solutions, especially in water, which has the highest boiling point? And options are 1 mole sodium chloride, 1 mole magnesium chloride, 1 mole urea, and 1 mole glucose. So here beta, 1 mole magnesium chloride has the highest boiling point in water, has highest boiling point in water. Next is your question number 9, and your question number 9 is which of the following aqueous solutions containing 10 grams of the solute in each case has highest melting point? Options are NaCl solution, B KCl solution, C sugar solution, and D is glucose solution. So which of the following aqueous solutions containing 10 grams of the solute in each case has highest melting point? Options are sodium chloride solution, potassium chloride solution, sugar solution, and the last one is glucose solution. So out of these following aqueous solutions that containing 10 grams of the solute in each case has the highest melting point is the sugar solution. sugar solution. So here option C is the right answer. So out of these following aqueous solutions that containing 10 grams of the solute in each case, sugar solution has the highest melting point. So option C is the right answer. Next is your question number 10, and your question number 10 is equal volumes of 0.1 mole AgNO3, that is silver nitrate, and 0.2 sodium chloride are mixed when the solutions of equal volumes, that is 0.1 mole AgNO3, that is silver nitrate, and 0.2 mole of sodium chloride solutions are mixed. Then the concentration of nitrate ions in a mixture will be 0.1 mole, 0.05 mole, 0.2 mole, and 0.15 mole. And it is a question number 10. So equal volumes of 1 mole AgNO3 and 0.2 mole sodium chloride solutions are when mixed, then the concentration of the nitrate ions in a mixture solution will be 0.05 mole, not 0.1 mole, not 0.2 mole, and not 0.15 mole, but 0.05 mole is the right answer for the question number 10. Next is your question number 11, and your question number 11 is the molar freezing point constant for water is 1.86 degree cm. The freezing point of 0.1 mole NaCl solution is expected to be 13.6, 68, 34, and 136. When the molar freezing point constant for water is 1.86 cm, then the freezing point of 0.1 mole sodium chloride solution is expected to be either 13.6, 68, 34, and 136. So the freezing point of 0.1 moles sodium chloride solution is expected to be 34. So here option C is the right answer, not 13.6, not 68, and not 136. But the freezing point of 0.1 mole sodium chloride solution is expected to be 34. So here option C is the right answer. Next is your question number 12, and your question number 12 is the solution containing 6.8 grams of non-ionic solute in 100 grams of water was found to freeze at minus 0.93 degrees Celsius if Kf for water is 1.86, then the molar mass of the solute is 13.6, 68, 34, and 136. So the solution containing 6.8 grams of the non-ionic solute in 100 grams of water was found to freeze at minus 0.93 degrees Celsius. Then if Kf of the water is 1.86, then the molar mass of the solute is 136. This is the molar mass of the solute, that is 136, not 13.6, not 68, not 34, but the molar mass of the solute is 136. So here option D is the right answer for the question number 12. Next is your question number 13, and your question number 13 is in case of electrolyte which dissociates in solution, the Barnes of factor I is greater than 1, less than 1, equal to 1, and equal to 0. So in case of the electrolyte which dissociates in the solution, then the Barnes of factor I is greater than 1, less than 1, equal to 1, and equal to 0. So there are 4 options for the question number 13. So in case of the electrolyte which dissociates in solution, then the Barnes of factor I is always greater than 1. So here option A is the right answer, not less than 1, not equal to 1, and not equal to 0. But the Barnes of factor I is always greater than 1. So here option A is the right answer. Next is your question number 14, and your question number 14 is which of the following salt will have the same value of Barnes of factor I as that of K4 Fe FeCN6. This is the which of the following salts will have the same value? The Wants-of factor as that of is. Options are Al2SO4 thrice, B NaCN, C AlNO3 twice, and D is Na2SO4. Which of the following salts will have the same value of Wants-of factor as that of K4FeCN6? There are 4 options for the question number 14. Right answer is Al2SO4 thrice. Al2SO4 thrice. So this is the salt that will have the same value of the Wants-of factor as that of K4FeCN6. So here option A is the right answer for the question number 14. Next is the question number 15, and the question number 15 is 120 grams of urea is present in 5 liter of solution. 120 grams of urea is present in 5 liter of solution. The active mass of the urea is 0.2, 0.06, 0.4 and 0.8. So when 120 grams of urea is specially present in 5 liter of solution, 5 liter of solution. So the active mass of the urea is not 0.2, not 0.06 and even not 0.8. It is your question number 15. But the active mass of the urea is 0.4. So your option C is the right answer. When 120 grams of the urea is present in 5 liter of the solution, then the active mass of the urea is 0.4. Next is your question number 16, and your question number 16 is the law stating that the relative lowering of the vapor pressure is equal to the mole fraction of the solute in the solution is known as. Option A is Henry's law, Wants-of law, Raoult's law, and Ostwald's dilution law. The law stating that relative lowering of the vapor pressure is equal to the mole fraction of the solute in the solution is known as Henry's law, Wants-of law, Raoult's law, as well as Ostwald's dilution law. And it is the question number 16. So beta, Raoult's law states that the relative lowering of the vapor pressure is equal to the mole fraction of the solute in the solution. Not Henry's law, not Wants-of law, and not Ostwald dilution law. But according to the Raoult's law, the Raoult's law, the relative lowering of the vapor pressure is equal to the mole fraction of the solute in the solution. So here option C is the right answer. And according to the Raoult's law, the relative lowering of the vapor pressure is equal to the mole fraction of the solute in the solution. So here option C is the right answer for the question number 16. Next is your question number 17, and your question number 17 is azeotropic mixture of HCl and H2O. HCl and H2O. Azeotropic mixture of HCl and H2O. Options are 48% HCl, 22.2% HCl, and 36% HCl, and 20.02% HCl. Azeotropic mixture of HCl and H2O has, it is your question number 17, 48% HCl, 22.2% HCl, 36% HCl, and 20.2% HCl. So with an azeotropic mixture of HCl and H2O has 20.2% HCl. 20.2% HCl. Not 36% HCl, not 22.28% HCL, and not 48% HCl. But azeotropic mixture of HCl and H2O has 20.2% HCl. So here option D is the right answer. Next is your question number 18. And question number 18 is, which of the following modes of expressing concentration is independent of temperature? Options are molarity, normality, formality, and molality. Which of the following modes of expressing concentration is independent of the temperature? Molarity, normality, formality, and molality. And it is the question number 18. So beta, out of these following modes of expressing concentration, it is independent of the temperature is molality. Molality. Not molarity, not normality, and not formality. But molality is independent of the temperature. So here option D is the right answer for the question number 18. Next is your question number 19. And your question number 19 is, a 500 gram toothpaste sample has 0.2 grams fluoride concentration. Fluoride concentration. So what is the concentration of fluoride in terms of ppm level? Options are 250, 200, 400, and 1000. A 500 grams toothpaste sample has 0.2 grams fluoride concentration. So what is the concentration of fluorine in terms of the ppm level? So the concentration of the fluorine, in terms of ppm level, is 250. So your option A is the right answer for the question number 19. That is 250, not 200, not 400, not 1000. But 250 is the concentration of the fluorine in terms of the ppm level. Next is your question number 20. An aqueous solution freezes out minus 0.186 degrees Celsius, that is Kf is equal to 1.86 degree, Kb 0.512. So what is the elevation in boiling point? Options are 0.186, 0.512, 0.86, and 0.0512. So what is the elevation in boiling point? So elevation in boiling point, what is the elevation in boiling point? Elevation in boiling point is 0.86. So here option C is the right answer, 0.86. This is the molar elevation in boiling point. So the elevation in boiling point is 0.86. So here option C is the right answer. Next question number 21. The average osmotic pressure of the human bipod is 7.8 bar at 37 degrees Celsius. So what is the concentration of an aqueous solution of sodium chloride that could be used in the bloodstream? Options are 0.15 mole liter inverse, 0.30 mole liter inverse, 0.60 mole liter inverse, and 0.45 mole liter inverse. So the average osmotic pressure of the human bipod is 7.8 bar at 37 degrees Celsius. So what is the concentration of the aqueous solution of sodium chloride that could be used in the bloodstream? Options दिए गए हैं and it is the question number 21. That is 0.15 mole liter inverse. 0.15 mole liter inverse. So this is the concentration of an aqueous solution of sodium chloride that could be used in the bloodstream. So here option A is the right answer for the question number 21. Question number 22. Which has the minimum osmotic pressure? Options are 200 milliliter of 2 ml sodium chloride, 200 ml of 1 mole glucose, 200 ml of 2 mole urea, and all have the same. So which has the minimum osmotic pressure? Options दिए गए हैं 200 mole of 2 mole NaCl, 200 milliliter of 1 mole glucose, 200 milliliter of 2 mole urea, and all have the same. So with a 200 milliliter of 1 mole glucose, 200 milliliter of 1 mole glucose. This has the minimum osmotic pressure. That is 200 milliliter of 1 mole glucose has the minimum osmotic pressure. So option B is the right answer for the question number 22. Question number 23. Solution A containing 7 gram liter inverse magnesium chloride and solution B contains 7 gram liter inverse of sodium chloride. At room temperature, the osmotic pressure of option A solution A is greater than B. B. Both have the same osmotic pressure. C. Solution B is greater than A and D is can't determine or cannot determine. If the solution A containing 7 gram liter inverse magnesium chloride and solution B contains 7 gram liter inverse of sodium chloride, at the room temperature, the osmotic pressure of solution A is greater than B. Both have the same osmotic pressure. Solution B is greater than A and D is cannot determine. It is the question number 23. Here beta, solution B is greater than A. Solution B is greater than A. So here option C is the right answer. Solution B is greater than A. Next question number 24. Equimolar solution in the same solvent है. Option A is same boiling P2 but different freezing point, same freezing point but different boiling points, same boiling and same freezing point, different boiling and different freezing points. Equimolar solutions in the same solvent है. Equimolar solutions in the same solvent have same boiling and same freezing point. Same freezing point. So equimolar solutions in the same solvent have same boiling and same freezing point. So here option C is the right answer for the question number 24, and it is our second last question for our today's live video lecture. And this is our last question for our today's live lecture, and your question number 25 is the mole fraction of the solute in 1 molar aqueous solution is 0.027, 0.036, 0.018 and 0.019. So the molar fraction of the solute in 1 molar aqueous solution is, that is not 0.27, not 0.036 and not 0.09, but 0.018. The mole fraction of solute in 1 molar aqueous solution is, if the mole fraction of the solute in 1 molar aqueous solution is 0.018. So here option C is the right answer for the question number 25. So here beta, this is all about for our today's live video lecture. That is important 25 MCQ questions or objective questions are to be discussed in our today's live video lecture, and the name of the chapter is chapter number 2, that is the solutions. And कल बेटे हम आपके साथ दोबारा एक नए लाइव वीडियो लेक्चर के साथ नए इंपॉर्टेंट एमसीक्यू क्वेश्चंस और ऑब्जेक्टिव क्वेश्चंस के साथ दोबारा मिलेंगे. So once again, good night to all the students who joined with us our live APS classes.